right, we are in geometry lesson 2-4. Today's date is September 29th, 2020. Beautiful Tuesday. Our objective today is to
determine when lengths and angles are preserved under multiple transformations.
Exactly. So just to give you guys a preview of what's coming up here, I'm going to be giving you guys like 4, 3, 5, some number of transformations, and then you guys are going to tell me are angle measurements preserved, are segment lengths preserved, maybe both, maybe neither. And you have to know just by looking only at the transformations. I'm not giving you any shape, any point, or anything. You just have to be able to know, oh yeah, rotations. Those preserve lengths and angles. Vertical stretch. Those preserve what again? So we're going through the notes again. Yes, what?
I know the answer to number 1.
What is it?
I think it's A.
It actually is not. But it's a good guess. I said A2 and I got it wrong last night on con, so maybe it's a good idea that I... And then there's only one thing that I want to say for the notes, and that's the mistake that you probably made right now, too. All right, so what are the 3 rigid transformations? Quiet raised hand. Who's got one of them? Ugo. Reflection, that's one of them. Give me another one. Emma. Translation. Give me the last one that we have. Ulysses. Rotation. There are only 3. There they are. Okay. Every sort of rigid transformation in geometry preserves these 2 things. I'm looking for one simple word here. Charles?
Length.
Length and Wyatt?
Bang.
There it is. Right in the length and angles. All right, nod your heads. We remember that. That's pretty easy. Okay, let's get into the stuff that would still kind of review that's good to know. There are actually 2 sort of non-rigid transformations. We've talked about one of them. Does anyone remember one of the non-rigid, Asha?
Dilation.
There it is, dilation. That only preserves one thing. Kira?
Angles.
Angles, not lengths. So maybe I can write off lengths to the side and say lengths, not you. But there's another non-rigid transformation. In fact, there's quite a few that I haven't talked about. There's like shear that we'll never talk about because it's kind of hard. Actually, when you get into pre-calculus, I could totally go on a tangent on how to do a matrix manipulation on how to do shear. But for now, we're just going to do the other non-rigid transformation, which is a stretch. And you're like, wait, isn't that a dilation? Not really. So stretch. Oop, I need to go back to blue. It is super, super similar, but typically speaking, especially for the homework tonight, it's going to be in specifically one direction. It doesn't scale out from one point. It's strictly in one dimension. It doesn't preserve anything. So if you kind of think about a shape that, maybe I can do a picture off to the side, but it preserves nothing. All right, here, nothing. If I have a triangle, let's do like some sort of equilateral triangle, 60, 60, 60 angle, interior angles. If I do a horizontal stretch, horizontal being this way, right? If I horizontally stretch it, you guys can see that this turns into, it doesn't get any taller, but check out this angle right there. The angle is clearly not the same. Lengths are clearly not the same. I mean, look at that length down here. It's definitely not the same length down here. So it doesn't preserve anything. Charles, question.
On a rectangle or a square, like if you do a horizontal stretch, it'll wait.
You're seeing that it could be a maybe instead of a never?
It'll say, yeah, maybe.
Yeah, you're right, yeah. So, for example, if you have a rectangle and you're trying to stretch it horizontally, then yeah, this length and this length are going to be preserved. But typically, like if I have some weird, like if I'm, I don't know, stretching it at an angle of 39 degrees, it's really hard to get that rectangle perfectly so that it doesn't stretch. So typically, it's not going to preserve anything. Actually, I should probably leave those pictures on here just for future reference. Chunk, chunk. All right, so let's do example 1. I don't know why I put so much space right here. I'll have to change that later. Okay, so example 1. Which of the following must be preserved under the following sequence of transformations? You've got a rotation, then a reflection, then a dilation, then a vertical stretch. Thinking about what preserved. So let's go through. I mean, you guys can jump right to the answer, and that's awesome. Let's just do a poll real quick. What do you guys think the answer is? Is it A, 1, 2, 3, 4? Is it, yeah, angles are only segments. Both angles and segments are nothing. Hold up fingers. What do you think the answer is? And we're going to go through this really slow, and then the next one we're going to go faster. Okay. And those of you that are holding up your hands, you got it right. Let's talk about why. It's neither. But why? So, rotation. Let's go ahead and list the two things that are still preserved. Rotation preserves what with a quiet raised hand? Asha?
Length and angles.
I can't spell Length, length and angles. Those are still both in the game, and because I have technology, I can go as fast as I please. Come on, I just want to grab things. There we go. And I'll just copy and paste this down here. So length and angle. Okay, after a reflection, are length and angle still preserved? You can nod your head vigorously one way or the other. That's a yes. What about a dilation? Length and angle, are they still preserved? No. Okay, quiet raise hand. Which one is out of the door? Kira.
Length.
Yeah, we would cross off lengths. Ah, why? Okay, hold on. Computer, be nice. My watch is going crazy too. Length and angle, and then I come back up here, and I can cross out. Yes, dilation gets rid of length. And then what about vertical stretch? What?
Vertical stretch, that will preserve nothing.
Preserves nothing. And it did the same thing again. Preserves nothing. So length was already crossed out from the last one, and now angle is crossed out as well. So maybe I can say last one was black, this one is orange. So nothing is left over after vertical stretch. Therefore, the answer is D. All right, give me a fist of 5. How old do you think you can do these? For the next one, I don't have any 2s or 3s, so no questions. All right, let's do the next one kind of quicker. All right, we have a translation, then a reflection, then a rotation. Translation, reflection, rotation. Okay, angles, only segments, both angles and segments, or nothing. What are you guys thinking? Only one of these answers is correct. And the answer is, you guys have it correct. 3, yeah, it's everything. Both angles and segments. These are all rigid transformations. Questions? Yeah, so nothing is thrown out the door. There's no dilations. There's no stretching vertically or horizontally. We're good. Example number 3. We have a reflection, a rotation, a dilation, and then a reflection. Lots and lots of things. Reflection, rotation, dilation, reflection. What are you guys thinking? The ones have it. Yeah, it's angles. Because we have a dilation, which throws out lengths. So this dilation will throw out lengths. And everything else is preserved. So the one question that I have for you guys, the high-level question that I can ask for today is, when will you ever choose option B? What sequence of transformations would let you choose option B? Any ideas? Jade? So just having a stretch? Oh no, because if you have a stretch, then it automatically turns into a D. But good guess. Asha?
I don't think there is one.
Yeah, you're right. There isn't anyway. Guys, never choose B. You'll definitely get it wrong. All right, thank you guys.
So when in doubt,